Hey, my name's Derek. I'm the CTO at Reown, formerly known as WalletConnect. Thrilled to be here. I really love this conference. I was here also last year. I think it's one of the most hardcore tech conferences here at Denver. So yeah, I'm very honored that you welcomed me back after last year. So what I'm going to be talking about is what we built in order to decentralize WalletConnect. I assume a lot of you are familiar with WalletConnect. And ultimately, when WalletConnect was started almost 7 years ago, there was a much stronger decentralization ethos in the community. Today, we hear way less users actually demand decentralization. But back in the day, we heard a lot of end users who demanded a decentralized network. And over the last years, that shifted more towards wallets that demand decentralization. So for instance, some of the big wallets using WalletConnect, such as Fireblocks, or big wallets in terms of volume, their entire business depends on WalletConnect being up. So they really want don't want a single point of failure. So it shifted more towards wallets demanding this from end users. And so that was sort of the motivation for decentralizing WalletConnect. Today we have 16 nodes running, 16 node operators running WalletConnect nodes. So yeah, it's quite an accomplishment. And what we actually ended up building is a currently permission federated key value store. And it's moving the needle in computer science because to my knowledge, nobody has ever done it before. Obviously, ultimately, it's going to be a permissionless key value store. And I'm very excited to talk to you about that because I think this might be a relevant primitive for some other applications. And I'll go into details there. And we're also talking to some design partners there already. But first of all, what did we actually build? What's the use case? So yeah, WalletConnect, you basically connect your wallet that's often in a different context, often on your mobile phone or in like a custody wallet, and you want to connect to an app like Uniswap to carry out transactions there. And in the flow there's some state. So it's not a stateless application. The state is what we call a mailbox. So when one client is offline, for instance, when your mobile phone is offline, which is a default use case, because the operating system kills the connection, then the app still wants to send a signature request, and then you open the wallet again, and the operating system terminates the app. So WebRTC doesn't work, and ultimately we need some state. So where do you store that state? So the initial idea is you just store the state in blockchain because you can store it there. The problem is that by design, blockchain is very slow because you broadcast the state to every single node. And you can argue that WalletConnect is already too slow, but definitely we can't wait like 200 milliseconds or whatever to broadcast to the entire network. So that meant we couldn't just use a blockchain, and then all the other technologies that were available off the shelf, like gossip-based solutions, are also too slow. So nothing decentralized off the shelf was available, so we decided to build our own. And the solution that we ended up doing is we built our own database. So basically we copied more or less, or we drew inspiration from Cassandra and other databases that are all based on a system or on an idea that's called rendezvous or consistent hashing. And they are all decentralized by design. The design goal there is not permissionless or censorship resistance or anything like that. The design goal there is to not have a single point of failure, such that you can scale up and down horizontally pretty fast. Also, Daniel, you mentioned Akamai. Akamai initially invented consistent hashing. I think there was a paper in 1995. And then what we brought to the table, or what we are bringing to the table, is a permissionless version of that. And so basically, there's blockchain, which is the world computer. There's Arweave and Filecoin, which try to be file storage. And now there's WalletConnect Network, which is a document store. And there's many use cases that need a document store, namely many DePINs, and today we are DInfra. Many DePINs that want to decentralize need a document store. So some examples are, last year here at DInfra I was talking about smart sessions, and Luca from our team is driving a standard there. The use case is that you can grant a permission to an application such that when you're using the application, you don't need to sign anymore. So for instance, we currently have some games and AI agent projects integrating that, such that you can play the game and performing an on-chain action without actually confirming the transaction. And you do that by granting a permission to the app. And then the permission policy is stored in this network such that you can manage the permission in any wallet. And you're not vendor locked in, and ultimately you also can't be censored. Then other DePINs have a need for this. For instance, Across is an orchestrator, and blockchain is way too slow for that orchestrator. So it's a nice new primitive. 2 more minutes, yeah. Thank you. So here's a brief overview what this looks like. This is basically what consistent or rendezvous hashing looks like. And basically each of these nodes, in our case, would be operated by any of our node operators. Some of them run multiple nodes. So this is basically this is what Cassandra looks like. This is what MongoDB, DynamoDB, and whatnot looks like on a high level. Then what we bring to the table here is an incentive layer as well, because obviously the node operators want to be rewarded. They're not philanthropic. We drew inspiration from many other teams on this. 1KX helped a lot in designing the incentive layer. Currently, it's still permissioned and federated, and we don't have slashing yet, so we're kind of in the same spot where Eigen and Symbiotic and some of these other projects are. We're drawing inspiration from them for the next phase, and the next phase is making this all permissionless, and we're going to publish a paper later this year on how we're intending to make this fully permissionless. And also, we're pushing the needle on computer science a little bit as well this year, because we want to make rendezvous hashing. We want to add some properties to rendezvous hashing, so we want to make it geo-aware. Basically, right now, all these nodes run in 3 different regions. Node operators have to be in 3 different regions, but such that you can run anywhere and you can run on your local machine. And basically, the rendezvous hashing algorithm just takes into account that maybe your machine is a bit slower or you're in a poor latency region or something, but you can still operate the node. And that's it. Thank you. We published a paper on this today, so check it out. Thank you.